Alright, today you're going to learn how to solve systems of equations by elimination using addition or subtraction. So we're going to solve now, instead of graphing the systems, we're going to solve it algebraically. And then once you have solved it, you're going to determine whether the solution to a system of equations is one, infinite, or no solution. A system of equations is two or more equations. A no solution means the two lines are parallel, they will never intersect. They also have the same slope but different intercept. One solution is when the two lines will intersect at one point, and you'll be identifying that one point, and that slopes are different. Infinite solution is when you graph a line, and when you graph the second line, it graphs as the same line. This occurs when you have the same slope and intercept. The elimination is one process used to solve systems of equations. Your first step in using the elimination method is to choose a variable to eliminate. So if your variables in your equations are x and y, then you would choose to either eliminate x or y, and we eliminate them by creating opposite coefficients. Opposite coefficients, for example, if you have a 5x plus 2y equals 13 on one equation, if you're looking at eliminating the x's, you need to create a negative 5x so that these two numbers, the numbers in front of the variable known as coefficients, are opposites. Once that occurs, then you can add the two equations. Okay, your next step is to solve for the remaining variable. When you add the two equations in step 2, you eliminate one of the variables, so you only have one variable left to solve for in step 3, and that is usually done by multiplication or division. Step 4, once you know the variable from step 3, you're going to substitute that into either equation and solve for that other variable. And then the last step is to check your solution for both equations. So here's our first equation. You're going to look at, first of all, deciding which variable to eliminate. What I always look at are the coefficients, and if there aren't coefficients, like on this one, both of those become 1s, and because those are the same number, 1 and 1, then I'm going to look at those two and create opposites. To create opposites, I'm going to look at the sign. Here's a negative, here's a positive, so right now those two values are opposites, and I can go ahead and add the two equations. When I add these, I get 2 plus 3 is 5x. The y's subtract out, so they are eliminated, and then I add the 6 and the 24 to get 30. Then to solve this, we divide by 5, and x equals 6. So we have found out what one of the variables is. So once you find out what one of the variables is, you put it into either equation, top or bottom. Now I'm going to look at the bottom equation because all my signs are positive. So I have 3. I'm going to replace the x with what I know it to be right here, a 6. So I put that value in, and I write the remainder of the equation. And then we're going to solve this equation. To solve this equation, we multiply 3 and 6 to get 18. And then to get y all by itself, we subtract 18. So y equals 6. So our solution in this case is one solution. Oops, that was sloppy. Located at 6, 6. And that's where the two lines intersect. The last step says that we have to check these. To check these, we put those values into both equations and solve them. So I'll do that in a different color. So the top one has 2 times 6 minus 6 is supposed to equal 6. I substitute in the x and the y right here. And that gives us 12 minus 6, which is 6. So I know that checks in the first equation. In the second equation, we have 3 times 6 plus 6 equals 24. So 3 times 6 gives us 18 plus 6, and that is 24. So it checks in the second equation, so that tells us that our solution is correct. Okay, on the second one, we're going to look at those coefficients. If you notice right here with the x's, I have the same number. Now our whole objective is not to have the same number, but to have opposites. But if I see right now they have the same number, then I'm going to work with that variable. And because they have the same number, I want them to be opposites. I'm going to change the signs on the entire bottom line. And then I'll go ahead and add. So here I have a 3 minus 3 the x's eliminate themselves. I have 4 plus a negative 1y gives us 3y, and then 11 plus a negative 14 is negative 3. To solve this, we divide by 3, and y equals negative 1. So we are almost done, or halfway done. We have one of the values. So once I have one of the values, I look at either equation. I'm going to use the top one because I didn't change anything in it. I don't have to think about signs. So I have 3x plus 4 times y. We found y to be negative 1, so we substitute that value in. And you get 3x plus a negative 4, or just minus 4, equals 11. We're going to add 4 to both sides. Here, this will subtract out, and you get 3x equals 15. To get x by itself, we divide by 3, and x is 5. So we get one solution located at 5, negative 1, and that's where those two lines will intersect if we were to graph them. The last thing you'll do on that is to check your solution in both equations. So we have 3 times 5 plus 4 times negative 1, and hopefully that will be 11. 3 times 5 is 15, plus a negative 4 is 11, so it checks in the first one. We will check the other one, which says we have 3 times 5 plus y, which was negative 1, and that should give us 14. So 15 plus or minus 1 plus a negative 1 or minus 1 does equal 14. It checks in both, so we know that our solution is correct. Okay, we have a couple special cases here. I'm going to look at these x's. Because they are the same coefficient, I want them to be opposite, so to make them opposite I change the bottom row, all the signs, and then I can add. When I have changed those subtract, these subtract, and I get 0 over here, and then I get a negative 1 minus 1, which is a negative 2, or plus a negative 1 is negative 2, and here I have 0 equals negative true. This is not true, so because it's not true, we say this is no solution, and you can either write that out or write no solution using the symbols. This means that the two lines are parallel and they would never intersect. Your other special case looks like this. And again, we look and see these coefficients are the same number. We want them to be opposite, so I'm going to change all of the signs. When I do this, these will subtract, and this will those, and you're left with 0 over here. And then we have a negative 1 plus 1 to get 0. And right here, this is a true statement. Because it's true, we say there are infinite, if I can spell it right, solutions, or we can use that sideways 8 to represent infinite solutions. What that means is that these two lines are exactly the same line. Okay, so I ask this question a lot because kids have a hard time with it. It says, can you solve 0 equals 3x? The answer is yes, because there's a variable right there. To solve for that variable, we would divide by 3, and 0 divided by 3 gives you 0. So x is 0, and you can solve that equation. The second one says, can you solve 0 equals 3? There is no variable, so no. These are not equal, and that would indicate that there is no solution. Okay, we have a word problem. It says the sum of two numbers is 14. So that says the sum means we're going to add two numbers, set them equal to 14. We don't know what the numbers are, so I'm going to call them x and y. The second sentence says the difference of the numbers is 6. So we're going to subtract them and say it's equal to 6. Find the two numbers. So from here you want to recognize that we do have opposites right here. So because we have opposites, we're going to go ahead and add them. Now remember, if there isn't a coefficient, it's a 1. So I have a 1 plus 1 is 2x. These will subtract, equals 14 plus 6, which is 20. To solve this, we divide by 2, and x is 10. Once we know one of the variables, we're going to substitute that back in, and I would choose the top equation. All our signs are positive. So instead of x, I'm going to replace x with 10 plus y equals 14, and then to solve this, we subtract 10. So y is 4. So we would answer this by saying that the two numbers are 10 and 4. All right, that should take you to your assignment 5.2, solving systems of elimination using addition or subtraction.